See how this goes.
That gives me something for the outtakes, really. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
I'm Dan Maloney.
This is episode 260, KiCad 8, 2 weather stations, and multiple I2Cs. This week we've got tons of news in the news. One is that just yesterday, as we record this, 2 days ago as you're listening to it, I was on the Floss Weekly podcast, episode 772, Raspberry Pi from the man himself. It was an interview with Ibn Upton, and it was super fun. You know, you appreciate the hacker in a person when they're just talking about the sheer joy of designing chips to go on the 40 nanometer process level. Like, he's like, that's my favorite process scale to design for. You know, because the parts are big enough that you can make them do analog things and they have voltage tolerance, but you could still get lots of computing done. And I'm like, yeah, okay, man. But over my head, but only by a little bit. And that's kind of what's inspiring about talking to people like that, actually.
You're almost there. This is someone you could almost be, right?
Oh, I don't know about that, but at least I could understand and have a great conversation with them. I don't think it was off the record. He said that talking to the Hackaday crowd is like one of the great joys of his job because, you know, he's running a big company, right? So he doesn't get the time to geek out as much as he used to, but likes to really get down into the technical weeds. You'll find the Floss Weekly podcast hosted at Hackaday for the past couple months. So head on over to Wednesday back on the blog and you'll find a link to it. Give it a listen. I think it's also hackaday.com/floss, like free Libra and open source software, but also like dental floss. And the other thing I wanted to cover on the news section was a quick one, a video from Surly Dirtbag, an automotive locksmith on the Flipper Zero and car theft. I guess we covered this in the news here a couple weeks ago now. Some Canadian minister decided that the flipper should be outlawed because it's being used to steal cars. And we were like, oh, really? You can do that? And this guy is a former car locksmith, and he confirms what we all thought, which is that you can't do any of the rolling code, spoofing, interposing, jamming, retransmitting stuff with a flipper. The video's a neat talk about him going through what you could do with the flipper, and that is about 25 years ago, car keys used to have just straight up regular old RFID tags in them and relied on that kind of static send me a code number thing to verify the key. Still, you'd have to have the person's key and you'd have to clone the RFID tag inside it. I don't think that's very likely. And then you'd have to get the key cut for them. I mean, it's easier to just steal the person's key, and then you could steal their car anyway. So you don't even need the flipper.
Yeah, there's a lot lower hanging fruit around than that.
And every car in the last 25 years uses rolling codes on the key fobs. So those are really hard to steal and anticipate. And that leaves, I guess, the hack where you jam the transmission between the fob and the car and then replay it, so that the person walks away without realizing that they haven't locked their car. And then you can either replay that number or I guess just open their car and steal whatever, you know, rifle through their glove box or whatever.
Their 25-year-old glove box, probably.
I'm not a professional car thief, man. I just like playing around with radio. Anyway, I don't think the flipper is the right tool for the job here if you're looking to get in on a lucrative life of crime.
Yeah, and recently I read about CAN bus injection and how that's used to steal more recent cars. And the car they gave as an example in there was a RAV4, a Toyota RAV4, and it was like in the date range of the car we literally just bought. Like, oh man, now I got to go tell my wife. But it turns out that it's only for the cars that have the keyless start. So it's just you've got a fob and then you press the button on the dash and it starts up. We didn't get one of those. My wife insisted, no, I don't want to have one of those. I want a regular key. And I was like, well, yeah, you know, it's not that bad. Well, yeah, okay, it is. When you can punch out the headlight and or the fender well and then just connect up to the CAN bus and tell it to start the car, because they happen to put the headlights on the same bus as same segment of the bus as they put the ignition, and you can just kind of reach in there and get into the bus and tell it what to do. I'm like, oh man, I'm glad we didn't get the keyless.
That stuff's really interesting. I mean, cars are and have been for a decade now kind of rolling networks. And so they
Yeah.
have all of this like network security, but then they also have this kind of high reliability aspect to them. If parts of your car work by being networked together, you really need them all to work. So it's
Hmm.
a real trade-off between kind of security and reliability in inside cars. So I can see this. On the other hand, like, undoing the person's bumper and sitting there with your whatever CAN bus sniffer. I mean, I could see me sitting there with my laptop, and somebody's busted off bumper and some wires stuck to it, right? Like, that's not going to look suspicious.
No, but apparently they've got it streamlined down to the point where it's just a pocketable dongle, and you can just quickly,
Yeah.
slam it into the bus and be on your way with the car.
That's pretty cool. I mean, it's not cool for you if
No.
that's your car getting stolen, but that's a fun vector. I like that.
Mm.
I have to say though, I think that all of these remote keyless things have to be more secure than keys. Based on my experience, which was, and this is the funniest damn thing ever, I was kind of a little bit sleepy. I was coming home. It was late at night, grad school, parking lot. Unlock the door, hop in my car, and it's not my car at all. It was an identical colored Toyota Camry, same, year range or whatever, parked in the same row as mine, but it wasn't my car at all. But my key unlocked the door. What are the chances of that? And I started thinking about it, and it was just a regular, two-sided
Yeah.
car key at the time. And if they're a little bit
Yeah.
worn, the tolerances may not be all that good. I mean, we may have had identical keys, we may have only had adjacent keys. Maybe I wiggled it just right and unintentionally bumped his car lock door. I have no idea, but I opened someone else's car door with my key.
Yeah, yeah, I've actually had that happen, something similar too, where after a long time the key wears down enough and the lock wears down enough that anything will open it. I've put the
Yeah.
wrong key in my car and started it up and just like what? But hey,
Yeah. So I'm pretty sure someone would have to exert a lot more effort to get into my like rolling code keyless car entry car, right? Than they would to just like accidentally walk up to it with the
one
right
hopes,
other
yeah.
Camry key and walk in. But I was so freaked out. I was sitting down in someone else's car that I had just unlocked, and I'm like, there's this huge box of Kleenex there that I had to move out of the way to get to the gear shift. I'm like, this isn't my car. It was it was just so awesome.
That is confusing.
Hey, speaking of confusing, let's do what's that sound?
Oh man, you're gonna go there with this one, right?
This is a journey into sound.
What's that sound?
Phew.
Okay, here we go.
Go for it.
I've heard this. This is the never-ending ascending note, right?
Yeah.
Yeah.
Fantastic.
And I don't know how they do it.
That's lovely. Yeah, this is the shepherd tone. Congratulations. I count that as the
Shepherd
right
tone?
answer.
Okay. All
Shepherd
right.
Shepherd risset glissando, according to some
Ah.
of the correct answers here. I've heard it called the barber pole tone illusion, stuff like that, but you got it. So it seems to be going up in pitch all the time, but they're actually like shifting things in from up high and shifting things out down low. And so it's just kind of the relative composition of the various individual sine waves that make you perceive it to be an increasing pitch.
That's
They
pretty
keep
cool.
they keep filling them up at the bottom as they drop them off at the top, so it always sounds like it's going up. Apparently, a lot of people have heard this before. I thought it was kind of obscure, but I am apparently so wrong because we have 85 answers, of which 81 are correct. And the only wrong ones included accelerating electric motor,
It does sound like
electric.
that.
It does sound like the electric train motor or something. Yep, I got that. Vibration machine sweeping across the band, testing for vibration susceptibility. Oh, that's a good
I
one.
like that one.
That's an awesome idea, which it wasn't. And the last one was a spinning electron beam target in an X-ray tube, which I've also never heard.
That does eventually get to a one particular point.
Right.
It hits a plateau. I've definitely heard that before, being an X-ray technician for a while. So I've heard
Right.
that.
But you have to listen for long enough, I guess, right?
Yeah.
A lot of people in the comments described it as, creepy or unsettling. I guess there's that, right? It's a little bit
that.
it's a little bit weird, right? I've heard also one that goes the other way. You can do them up and down, and there are all sorts of variations on this, which is really fun. Apparently, it's been used in Dunkirk by Christopher Nolan
Ah, yeah, that movie. Yeah.
to build up tension in a movie. I think the best answer comes from DJ Escher. With DJ Escher at the turntables, the bass never drops. I think that's pretty sweet.
DJ Escher.
And absolutely best nickname this time is T left shift 10 bits anded with 42 times T, which is one of those. It's actually one of those repeating bit music things. It's one of the 1-bit music things. I'll have to do one of those sometime.
Yeah,
I didn't say that. Anyway, using a formula as your nickname is fantastic. Only on Hackaday. So yeah, 81-sided die. I'm going to fetch over to my random NIST randomness beacon routine for this one because too big to do anything else with. And I type in 81, downloads the latest random seed, and the answer is 33. So let's see who that is. Congratulations to Beeman, who wrote simply Shepherdstone. But yeah, that's right. It doesn't get righter than that. Congratulations, Beeman. I'll get in touch with you, get your shirt size, and get a t-shirt on its way out. Everybody else, thanks very much for guessing on this one. Your chance will come next week when I'll come up with another sound for y'all to guess at, and hopefully you'll get it right and be in the running the week after for yet another Hackaday Podcast t-shirt. All right, then off we go to the hacks. I'd like to start off with a talk from FOSDEM. Wayne Stambaugh every year gives his update on what's going on in KiCad. I guess when he gave the talk, they were just getting ready to release KiCad 8. I think it's out by now. It was release candidate 3 at the time. And he just talks about everything that's gone on in KiCad development over the last year. And I have to admit, I haven't been doing as much circuit board stuff lately, and I just updated to 7. How can they have 8 out already? You guys. I can't keep up. Interesting is that KiCad's got lots of sponsors from normal people like us, but then a bunch of corporate sponsorship too. And so they've had a lot of money to spend on developer resources. He said they picked up $200,000 in their last donation campaign. And this is one of those changes that I think is behind the scenes and kind of low key, but a huge quality of life improvement for all of us out there who use it, which is they've been able to spend a bunch of money on the library team, and they've got a new head footprint librarian and 8 new team members, and they put out a whole bunch of new symbols and footprints. And I think that he said the number is now up to 20,000 symbols and 13,000 and a half footprints, which he mentioned very diplomatically is larger than the libraries that some parts distributors have. Without naming any names, which is really great because when you have a part and you don't want to design the footprint yourself, it's really super to be able to just go pull it down out of the software, and having people who are actually like actively going through and looking after this library. It's a huge human effort and important for all of us users that these footprints are, well curated and accurate and all that. So that's kind of a not sexy as far as software goes, but completely fantastic for the users. On the software side, man, tons of things. Hard to put them all in under one hat. Like SVG exports. You can define alternate hotkeys for things now. ARM64 port. I think this means KiCad will run on a Raspberry Pi now. Complete import from Easy EDA. He actually had a slide with a big matrix of all the other different EDA tools that it can import from, and it's getting more and more filled out year by year. One kind of group of interesting developments this year was related to Git integration. They've got a Git tool inside KiCad now, but then a whole bunch of little things to make working with revisions and version control and your PCB design more seamless and pleasant, including they've got a command line to run the ERC electrical rule check and DRC design rule checks, which means you could hook this into some kind of a continuous integration framework and have your new designs automatically verified, automatically checked for their validity as you upload them. There's a new diff tool that they're working on, so you can see what the difference between two revisions of the same schematic are. They're working on a visual diff tool for footprints. It's all these little things kind of add together to make the revision control framework work better inside KiCad itself. And I think that's actually really neat because I have to say, I mean, I've kept my PCB projects under version control all the time. And when something goes wrong, it's just super nice to be able to say, hey, wait, what was it like before I messed up? And you can just roll back. This looks like it makes that even easier. Rounding it out, things like an internal BOM tool now. It used to be you'd have to load in external scripts to do it. Now they have a default one. It's kind of simple, but gets the job done, puts out a bill of materials. If you want to run the scripty ones that you've been doing before, you still can, of course. Contextual grid spacing is neat. So for instance, if you want all of your silkscreen on a really coarse grid pitch, you don't need to finely move them around, but then footprints can move like 0.1 millimeter increments and text can move on 1 or 2 millimeter increments. You can do that. So contextual grids for the different parts. I think that's really cool. A bunch of 3D viewer stuff, which, makes it look better. That stuff gets cooler and cooler looking all the time. I've never really used the 3D views except to go, oh, that looks really cool. But they are good if you have layout constraints, or if it needs to fit in a box, or if you need to know if the holes for the standoffs are in the right place or are going to collide with a capacitor or something like that. It's actually totally useful to have a 3D view of the thing. Step export files so that you can better work the boards you make into your 3D printed projects, for instance, afterwards. I don't know, just tons and tons and tons of stuff. None of it sounds like super, super revolutionary, but all of it sounds very happy and evolutionary. So if you've been using KiCad before, it sounds like none of this will, blow you out of the water or confuse you or make you redesign your workflow, but all of it is kind of well appreciable quality of life things. Wayne also mentioned in the talk the share of boards showing up at, granted, some of the hobbyist board houses, but at Osh Park and at Eisler here in Europe is growing year over year, and they've been reporting that share back to them. And I think it's something like 43% of the boards submitted to Osh Park are now designed in KiCad, which is pretty darn good for a scruffy little free software project.
Yeah.
With support from CERN and, tons of important businesses. And, it's become the real deal. It's like Linux used to be a scruffy little free software project back in the day before it runs
the world.
90% of the boxes on the internet.
First up for me, a smarter solar water heater. I can remember back in the 70s when the energy crisis came around and people were putting solar panels up on their roofs, but they weren't electrical solar panels. They were water heating solar panels because you couldn't possibly afford PV cells to put on your roof in the 70s when they were taking all those things and put them on satellites. And, you weren't putting that on your house. This is sort of that, except that it starts with PV and goes through to heating the water, which is a really clever way to store electricity when you think about it. This comes to us from someone named Rogan, who lives in South Africa, And he explains in the project that, or in the write-up, that there's an awful lot of brownouts and blackouts and rolling load shedding sort of things that go on in South Africa. So a lot of people have put PV panels up on their roof because they are sick of the unreliability of the grid. But as experience has taught me, the expensive part of solar photovoltaic system is not the solar cells and the panels themselves necessarily. It's the storage. Buying batteries is expensive. I mean, $2,000-$3,000 for a couple of kilowatt hours is a lot of money to put into a piece of equipment. There's got to be a cheaper way. Well, Rogan found a cheaper way, and that's by heating water. Water's a whole heck of a lot cheaper than lithium. And heating it with a resistive water heater, just like a regular sort of, everyday electric water heater, is a great way to store that energy at times when the panels are producing and use it later. The idea here is, though, that he needed to slightly modify a water heater to the specs. First of all, he dropped it down from a 3 kilowatt heating element to a 2 kilowatt heating element, so it would be able to be controlled by a 20 amp circuit. The actual control of the element in the water heater is done with this more or less straight off the shelf sawn-off relay. Those things have an ESP32 inside of them, and the problem here is that he wants to attach an external thermistor, not just use the simple bimetallic thermostat that's sitting inside of the water heater. All it does is turn the element on and off. It doesn't provide you any information about how hot the water actually is. There's no sensor in there. He wants to add a thermistor. Problem with that is the only input that's available for analog input on the ESP32 inside the sawn-off is the ADC2 connection, which is mostly used by the Wi-Fi. So if you've got Wi-Fi on, which sawn-off, part of its charm is its ability to talk Wi-Fi. If you've got the Wi-Fi on, you can't use the ADC. So he comes up with a couple of different options. And what he finally figured out was the best would be to make a little adapter board that takes the analog output of the thermistor and converts it into a one-wire connection that the ESP32 is easily able to handle, the ESP32 inside the sawn-off. So that gives him a thermostat or a thermal sensing means. And then the logic for controlling the water heater is basically done through Home Assistant, because ESP32 in the sawn-off, easy to put into Home Assistant. Their firmware does all that kind of stuff, so all the logic can be in Home Assistant. And I just thought this was a really cool little project. It basically is just a little fleck of PCB with an AT-Tiny 85, I think it is, and a thermistor that lives inside the water heater. And it allows him basically to kind of increase the hysteresis of the water heater. It makes it so that it can get colder than the stock thermostat in the water heater would allow, and it can also make it so it gets hotter. So when he has periods of time that the sun is shining and the utilization of the water heater is at a minimum, it'll maybe just put some extra heat into the water, get it a little hotter than it normally would, and store that for later when there's no sun shining. I thought it was pretty clever, and like I said, water's a whole lot cheaper than lithium. So it's a nice way to kind of get around that storage problem. The one thing I do worry about is, you've got now, he goes up to 70 C on the water heater, which for us in the United States, that's 158 Fahrenheit. That's pretty hot for hot water. And if you've got kids or old people or anybody, actually, you probably don't want to be dumping 158 degree water on them. That's pretty close to scalding. So hopefully he's got some sort of tempering valve in there that can kind of mix it in with cold water and get to a better temperature for showers or bathing or whatever. But he doesn't mention that, but I'm assuming he does, and he's got some sort of way of ensuring safety.
Or they're just really careful mixing it when they're...
Or yeah, maybe they're just willing to live on the edge. I don't know.
Hot water, if you're using it in your house, that's something you'd spend energy on heating. So it's a great way to cut that corner. That's really cool. Speaking of awesome home automation hacks like this, however, I have to say our home automation contest is
Ah,
still running. So plug. This would have been a fantastic entry into the home automation contest. I love that he's hacking into one of the sawn-off relays and augmenting it. I mean, please. That's fantastic. My next hack is educates.tv. ESP32 weather station looks great with color e-paper display. Man, speaking of things that would have been good in the home automation contest,
yeah.
it's a desktop weather station with a nice e-ink display. This one uses a color e-ink display, which looks pretty sweet in a little 3D printed frame. It's got an ESP32 in it. It actually pulls down the weather forecasts from the internet, but then temperature, humidity, and pressure are done from a local sensor on the board. It's a BMP 180. I love those chips. I'll sing their praises in a few minutes. But the other thing that I thought was really cool about this project is that he's also using the old school method of forecasting the weather, at least in the near term, which is to kind of look at how the barometric pressure is changing and say, oh, the barometer's dropping, there's going to be rain coming or whatever. But it turns out that there's a more scientific way to do this sort of ad hoc barometer-based forecasting called the Zambretti algorithm. And he touches on that in his video here and threatens to go deep into it in an upcoming video, which I think would be really cool. But basically, it combines a whole bunch of different factors, including barometric pressure change, but also temperature, what season it is, wind speed, things like this, and supposedly gives a fairly good near-term 12-hour forecast of rain versus dryness. And I think that's pretty cool by itself. And I'd love to see this thing compare the weather forecast that it downloads from the internet using, an API and API keys and the whole kind of modern hoo-ha with the Zambretti algorithm's predictions, because he's got all this data in one place. He really should just be saving it, and he can look at it later and say how good was Zambretti doing against the official weather service prediction. And I guess if he knew how much it rained outside, if he had a fancier weather station, he could even verify which one's better against reality. Anyway, simple device and some, fairly simple code going into it. Nothing here is ridiculously elaborate. It's just very nicely done, makes good use of a couple easy to get parts. I think it can't cost all that much money except maybe for the fancy multicolor e-paper display, but just looks good. It's most of the time in a deep sleep mode, so it's easy on the power. He estimates it's going to get a few months on the battery, but who knows? It wakes up every 6 minutes, fetches the weather forecast, reads the barometer, pressure, temperature sensor, and then writes to the e-ink display and then shuts itself down. And that is it. And if you go and look at his YouTube channel, he's got a ton of these kind of really nice, simple, getting started projects. And so if you're looking for inspiration for a simple weekend project for yourself or something to hook someone else on kind of hacking around with electronics, it's probably a good YouTube channel to check out. And this project is his most recent, and it's a pretty sweet one.
Yeah, I'd never heard of the Zambretti algorithm before. I'm going to have to look into that. I find that kind of interesting that maybe put together a few simple parameters and you've got a reasonable forecast. I kind of like that idea. Really kind of surprised that in the comments, the first comment is the DHT family of sensors are just, no good. Don't use them.
Yeah.
Is that, is that a thing? Is that what people are seeing?
I think that's basically true.
Is it? Okay.
I mean, they're fine.
Yeah, I had one lying around and I just threw it into a door controller that I built for my chicken coop. I wanted to automate that a little bit with Home Assistant. And I said, be interesting to see what the temperature is in there over the winter. And I did throw it in there, and it has been sort of, it reached a minimum at some point. Even though it was wicked cold outside, it was still just sort of hovering around at the same temperature, and it was just flatlined. So I think maybe there was something to that. It seems to be working okay now, but it has given me some problems. So I'm gonna have to look into that a little and see if it's the DHT sensor or if it's something else that's going on.
Yeah, I think some of the complaints people have against them is that they do some self-heating. So that might explain your minimum temperature, actually,
Oh,
is that some
yeah.
of the parts on board are creating enough heat that the temperature is inaccurate. But if you don't care that the temperature is off by 1 or 2 degrees, which, for a lot of applications you don't, it's probably totally sufficient. I'm gonna have to look it up. Man, there was once we covered maybe 8 years ago, like the ultimate temperature pressure sensor shootout. I'm gonna have to find that for you guys because it's astounding. Let me see if I can find that one real quick. It's humidity sensor shootout was the title. Oh, look who wrote it. Me. Oh, look, I wrote it
That's
up.
why you remembered.
It's easier when it's out of your own head, right? Yeah, so absolutely go check out the humidity sensor shootout post here. Let's see if it's still up. Yeah, it is. Yeah, and he goes and he characterizes them over various temperature ranges and etc. And I think response speed, this is the most amazing one. And the BME 280 beats them all hands down, and it's true. I did say I was going to rave about these things. I've played around with them. The sensor in the Bosch pressure sensors is so precise that you can raise it about 10 centimeters on your desk and you can notice a change in some of the least significant digits in barometric pressure. You can definitely tell the difference between the floor and your desktop using just based on barometric pressure alone. If somebody closes the door in the room, you get this gigantic spike in it as the pressure wave from closing the door comes through. And, like if you cough nearby, you can watch it spike up. It's really, as an absolutely fantastically sensitive chip. And it kind of made me realize that, barometric pressure sensors, especially ones that are this sensitive, are really just microphones for really low frequency. It's like a DC microphone, essentially. And so I imagine you could listen to really low tones with it as well. Like they're really crazy fun. The craziest hack I've seen with these is from 2012, man, long time ago now, using one of these MEMS digital barometer sensors. This was a group from MIT using it as a pressure sensor, as a force sensor. So they put 3 of these down on a PCB and they covered them up with silicone, and this provides like a force sensor. And so what you do is you'd press down on the silicone pad and it would push enough force down into the barometers that they would notice it. And what was neat about this is shown in the video demo that we have linked here, is they have an extremely wide range. And like I said, they can tell the difference between being moved up and down half a foot on your desk. They can tell when you put a 5-gram weight on it, but it also can survive when you clobber the thing with a hammer. And so it's a really neat sensor to take one of these like ultra wide range barometers, make it rugged enough that you can do stupid things to it, and then use it as, as a stronger environmental sensor, as like a mass force sensor, as a scale. I mean, there's just all sorts of crazy things you could do with these. And so I think that's the other thing that I got out of this. This is a really simple example, but it uses a really, really cool part that I think has a lot of hacking potential. So if you haven't played around with those MEMS barometer chips, you absolutely must.
So they are MEMS based then.
Which is really cool. I actually looked into how they work ages ago, right? And they work exactly like you think. They've got a little capsule with some air in it, and it's got a membrane, and this membrane has a strain gauge on it, basically, right? And so when the outside air pushes in on it, it gets strained one way, and it pulls on it, the membrane flexes the other way. And of course, this is MEMS, right? So it's all one of these like nanoscale things, but it's exactly like a barometer would work. It's a vessel with some air in it at known pressure, and then it has a deformable membrane. It's just on tiny, tiny, tiny scale. And I guess a super accurate ADC, and that's all there is to it. The fact that they can make them so ridiculously tiny, so incredibly sensitive, and they cost like $1 and they speak I2C. Like and you get temperature along for the ride, because temperature and pressure are related in
Yeah.
closed up gases, right? So they have to measure the temperature. And if you actually do raw analysis on these, there's a formula you have to use. If you're just going to read the temperature and pressure and then raw strain off, there's actually a formula you can use to turn that into barometric pressure if you want to do the low level calibration yourself and make it super accurate. Oh, that's a rabbit hole. And it's a rabbit hole you can get into for a couple bucks on a nice, convenient I2C module if you pick one up from any of the usual places. So get yourself one and play with it if you haven't.
Okay, over to the metal shop with this one for me. There's Hope for That Cheap Lathe Yet by Camden Bowen. This caught my eye because this lathe that he features in this video is one of the clones. There's so many of these mini lathes that are all apparently made by the same company. They're all the same castings. They're all the same controls. Everything about them is the same, down to the little cheap plastic angle scale on the compound slide. Everything about them is the same. The only thing that seems to change is the branding on it and the colors that they tend to paint them. These lathes are all over the place. This one came from Vevor because apparently everything comes from Vevor now. But basically, it's the same kind of lathe that you see on a ton of different project channels. And when you get it out of the box, it's pretty cheap. I think he said he paid $7.74 for it, and I think that was Canadian. Let's be honest, it's a crappy lathe right out of the box. Jenny puts it well, a lathe-shaped object. And that's pretty much what it is. But there's hope for it because you can put a whole bunch of modifications into it and turn it into something decent. The first place that most people start, and Camden did indeed, was replacing the bearings in the spindle. They basically put in cheap ball bearings. There's 2 ball bearings, one on each end of the spindle. They don't have any axial load handling capability, so when you push into a part, like to face or something like that, you're putting all that force into basically an unsupported aspect of the machine, and that's not so good. So replacing those with tapered roller bearings rather than ball bearings is usually the first order of business with these. And it goes through a whole bunch of other changes. I've seen a bunch of videos where people are trying to make the best of their mini lathe, or as this old Tony refers to it, a manila. I mean, he puts a quick change tool post on it. He had to put a carriage stop on it so that you could actually lock it down for facing operations because they didn't have one of those. What else? And just simply bolting it down to the bench, it does wonders for stability and making sure that it's not you're not chasing it around the bench while you're trying to do operations. It's funny. I remember I think it was even Quinn Dunkey who said, you buy either a new lathe and get to work, or you buy an old lathe and you've got a project. Well, it seems like with a new lathe, if you buy one of these cheapies, you've got a project too.
Why not both?
Why not both, and why not? To my way of thinking, it seems like you've got, with one of these cheap lathes, you've got a good solid basis for making the changes you need to make to the project aspect of it is pretty well known. You've got to replace the spindle bearings. You've got to take care of the ways. They're always kind of crusty and gummy. You've got to replace the scale on the compound. You've got to bolt it down. You've got to do something about the terrible tailstock. All these things you have to do. So they're known quantities. Whereas if you buy an old South Bend or Monarch or something like that that's been in a shop for some amount of time, you have no idea what you're going to need to do. You might need to do nothing. You might need to replace just a few things. You might get it home and find out that the ways are completely worn down and there's not much you can do about that. So you've got a lot of unknowns for the project. At least with these things, you've got knowns that you need to take care of because a lot of people have done the same thing. Kind of to my way of thinking, kind of these make more sense than an old lathe. Although who wouldn't want a nice old South Bend if you could get it, compared to one of these cheapies. There's probably an in between too. Quinn has actually done some videos on her choice of machine tools and both her mill and her lathe and upgrades that she's made by completely replacing the machine rather than trying to take a small machine and make it into something it's not. at the end of the day, any lathe is better than no lathe, and that's pretty much what I have right now. So seeing things like this kind of gives me some hope that, spend a few bucks, get something, and just get to learning turning.
Yep.
He's way ahead of me, so I'm not going to complain about his crappy lathe because it's better than mine, not a lathe.
We picked up one for our hackerspace that was, also not good old steel or not top of the line either. And one of the things we changed out was the tool posts and stuff, which really helped. Some of the ways things are attached to this are just so inconvenient to move one tool out and the next one in and stuff. Like just some of the creature comfort aspects can really be improved on for sure. And, like you say, we had to take the whole thing apart, put it all back together. If you do that, you can get something fairly reasonable for it. And I like that take that, some parts of it are crappy, but at least it's a known quantity. I hear you. I hear you.
I can't count the number of times I've said to my wife, like, we got to go to the hardware store. Why? Well, because I don't have a lathe.
Right. Right.
Well, what do you mean? Well, yeah, I could make this part. If I had a lathe, I wouldn't have to go to the hardware store. Oh, okay. Well, let's go to the hardware store.
Damn it.
Yeah.
Nice try, though.
Foiled again.
My next hack comes from AeroPic. This is a wireless telescope guidance system you can build on the cheap. And by cheap here, it's really cheap. I mean, I think we're talking kind of $10, $15 worth of parts here. That's really neat what he's done. He's built an altitude azimuth mount for his telescope and then outfitted it basically with sensors telling it where it's positioned. And so he's got two really big gear wheels that mesh up with some smaller gears so he's got a serious gear ratio going on. The smaller ones have a magnet on them and one of those magnetic rotation sensors, AS5600, for those of you playing along at home. And that plugs into an ESP32. Each axis is its own independent wireless device. So there's a battery that goes with this ESP32, and that is it. The two axes talk to each other over ESP now, so there's no wires anywhere in this thing. I think that's really kind of a neat way to build it. And then one of the ESP32s is also connected by Bluetooth to a phone app, and the one he's using is called Sky Safari, but apparently there are a whole bunch of them. And there are a bunch of protocols that they speak to let you interface with like a sky map. You say, I want to go here, and then you point the telescope and you can see on the sky map in real time where the telescope should be pointing in the real world, courtesy of these two geared sensors on altitude and azimuth. It's like a digital readout basically for your telescope, except it's also coupled with this map. And I guess the last step is that, of course, you have to calibrate it in there, and that is done inside the app. You actually say, point your telescope at this star, press this one, point your telescope at this star, press that one, and then it backs out what the gear ratios are and how many degrees it moves for how many turns of the little wheel and all of that. And so then it knows where your telescope is pointing in the sky, and you take it from there. And so then you can kind of flip around on your cell phone, say, I want to look at Betelgeuse. You press on Betelgeuse and it says you have to go over this way, and it tells you when your telescope is pointed in the right direction. In the video, you can also see that he's got motors and it looks like that Dyneema fishing line or something. He's got a capstan drive with some stepper motors. I think he's going to take this the next step and make it fully automatic pointing eventually. But this is just a really cool project because it shows you what you can do with a super minimal setup. And that is, a couple big 3D printed parts. Oh, a neat part about the 3D printed parts, he uses timing belt glued onto the big one so that he doesn't have to print the teeth on it. So he uses that instead of the gear teeth, just like timing belt adhered to this big semicircle. And that's it. I mean, there's not much more to the hack. I just thought it was super cool that you can basically take stock ESP32 modules, a stock magnet sensor. He's got a couple, it looks like he took those snip off cutty bits from LEDs and like bent them the right shape to plug into the female header on the magnet sensor and then put a battery on it. Like that's literally all there is in terms of hardware to these two axis sensors, the gears, the magnet sensor, the ESP32, a battery. Minimal construction, no PCB necessary, just bam, 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 parts off the internet, go. The rest is taken care of by some clever software between the two axes, and then, of course, nice, fancy interface software on your cell phone.
Okay, last up for me, 3D printed automated development tank for classic photo films. I tend to pick up any of the wet darkroom hacks that we see. We don't see that many of them, but when we do, I pick them up because I loved working in the darkroom. A lot of photographers back in the analog days couldn't stand darkroom work, and for some reason I just loved it. It was like magic to watch the actual images show up on a print in a tray of liquid, and just, this ghostly image just sort of comes up, and then bam, it's there, and you see what you did, and you get this instant feedback that was really cool. Of course, now you get instant feedback by looking at your phone. But I guess that doesn't have the charm of being in a dark room. Packet Andy, however, did identify a few tedious points that could use a little tune-up. One of them is the agitation of the film in the developing tank. You pour the chemicals in, and then you've got a specific amount of time that you have to bathe the film in the developer, the stop bath, the rinse. You got to be pretty careful about agitation too, because you don't want stale chemicals to be in contact with the film for too long. You want to get a fresh run of chemicals. You've got to worry about heat. There's all these fussy things. So this device that Packet Andy came up with is basically automating the one task that you don't really want to necessarily do, which is the agitation, by sticking a stepper motor onto the agitator of the developer tank, and then using a basically off-the-shelf stepper motor controller. So nothing fancy. No, he didn't try to roll his own stepper motor controller or anything. Why do that when you can buy one? It's not the most interesting part of the build. Put the two together, and it takes care of all the agitation that you need to do during the development process. Thought it was pretty clever, and like I said, anytime I see a wet darkroom hack like this, it makes me nostalgic for all the time I spent in the darkroom back in the day.
Like, that's the same film development tank that we had. The same. There must have been like two brands that made them, but that's exactly the one we had. We had this like super tall one. I used to work for the college newspaper. We had this like super tall one that you could put multiple spools. We had them in like 2, 4, and 6. And the 6th one was just like really long. It's too funny. Yeah, I used to just walk around sloshing the thing all the time, just continuous agitation. That probably has reasons you shouldn't do that too. Who knows? Like everything else, it gave you some time to talk with your friends and, do nothing for the 10 minutes when you're developing film, because, you gotta sit there turning the knob.
Yeah, I used to walk out into the newsroom. I did the same thing. I was a stringer for the college paper, and they just threw me into the dark room, said develop your own stuff. So I'm like, okay. When I was doing the agitation, I would just walk out into the newsroom and see what they were doing.
Yeah, totally. That brings us to the quick hacks. This week, I'd like to start out with Voltative's video, the photodiode you never knew you had, or maybe you did. Maybe it's a little bit of a clickbait headline, but the idea is that LEDs are also photocells if you run them the other way. I guess I would claim that a lot of us know that, but what's really cool about this video is that he actually quantifies how much voltage and current he gets out of, a red, green, and a blue LED. And it obeys the laws of physics. And then he strings them together and runs a calculator with it. So he takes one of the solar calculators, pulls the solar cell off, runs it with an LED, and then as his last trick, it actually has a red LED on the circuit board somewhere, and he holds it up to a bright enough light that the thing fires up just off of its little indicator LED. And I think that's pretty sweet. Next up, Bastelbau's avoid I2C address conflicts on ESP32 by pin muxing. This is the Achilles heel of I2C, and actually it's funny, I was talking about that MIT pressure sensor thing. They even mention it there. If you use multiples of the same I2C device, they often have the same address, so you can't put them on the same bus. This solution here is really clever. The ESP32 has an internal pin mux so that you can say, I would like the I2C peripheral to be on this pin and this pin. And what he's doing here is he's changing it dynamically. So he has two different I2C devices with the same address connected to different GPIO pins. And then in the code on the ESP32, he's saying, okay, now attach the I2C bus to this set of pins to talk to this device, now to this one to talk to this device. It totally abuses the ESP pin mux to turn it into a multi-bus I2C platform. Really clever. In the comments, Rogan Dawes comes in and says, you could do this with UART too. And of course, he's correct. As long as you don't need your different UART connections simultaneously, you can just move it around and have a whole bunch of things connected to different virtual serial ports. Sweet idea. Last up, Jan Stech Blast from the Past schematic templates. These are 3D printed stencils basically for drawing circuit schematic parts. And it's just a really sweet idea. Quick and easy 3D print lets you draw very crisp diodes and fancy looking potentiometer symbols. If I had to draw schematic diagrams by hand, I would make myself a set of these in all different scales.
That's funny. I've got an entire briefcase full of schematic stencils sitting here.
Do you really?
Yeah, my father-in-law was a PCB designer before computers were a thing, and he did all his designs by hand. And we got his briefcase. It's kind of a cool briefcase. I was actually thinking about doing an article on that. This is how it used to be done.
Absolutely.
Maybe I'll work on that.
Do it, because I didn't even know this existed. This was news to me that such things existed. And
really?
Of course, it looks super professional. So really cool.
Okay, first up on Quick Hacks for me, Solar E-Ink Weather Station works on dark days too. This kind of calls back to the E-Ink Weather Station that Elliot was talking about before. It's got a little bit in common with it. It's got the E-Ink display up front, and it looks sharp. Overall, the fit and finish is super. This one only has a 2-color E-Ink display, which I love, and I love weather too, so this really pushes my buttons. I believe this one gets all its weather information from APIs, but that's okay because usually that's pretty good information. It also has a solar cell on the back of it, so you mount it in a window and it runs on the sun. This is from RS Apiawaf or something like that. I'm not sure what the handle is. But anyways, they put this ESP32 S3 Mini in there and did some mods to keep the power consumption as low as possible. It looks like it gets quite run off of just a few bits of sunshine. Next up, Your Scope Armed and Ready. This one comes from Voltlog and takes advantage of the little known fact that there is a VESA mount on the back of a lot of digital oscilloscopes. Of course, I saw this and immediately looked at the back of mine, and no joy, mine doesn't have a VESA mount. However, if yours does, you could maybe get a monitor arm, an articulated monitor arm, and float your scope over your bench. I think that's a great way to free up a little bench space and to kind of take care of the problem of leads draping from your scope to your project and getting tangled up in whatever else you've got on your bench. Kind of like the idea. I also kind of think maybe you could use the same kind of articulating arm to mount a microscope. To look into that. And last up for me, making a dye-sensitized solar cell is almost DIY-able. This one comes from Shiwei Che. This uses relatively accessible chemistry to build solar cells on sheets of FTO glass. And that's what? Fluoride tin oxide? Fluoride? I forget. FTO glass. That's specially prepared glass that you basically coat with this dye and then platinum and silver and make your own solar cells. Kind of cool. Again, the chemistry is maybe not so approachable as, stuff you've got around the kitchen, but it shouldn't be too hard to find the stuff you need to do something like this.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I got Al Williams's Ask Hackaday, what if you did have a room temperature superconductor? And of course, there have been all of these recent claims or hints or whatever that people are working on a new class of high temperature superconductors. And so this was Al just kind of saying, well, what would happen if this were actually true? And he kind of breaks it down here. It's a really neat think piece. When you cool some metals down near absolute zero, the electrons can move in pairs kind of freely through the lattices that are formed there, and that's what makes superconductors do. The question is, can you do similar tricks at higher temperatures and even up to room temperature? The answer is sure you can at extremely high pressures, and well, that's not very helpful either. So then the question is, can you do it at room temperature and room pressure? And the answer, of course, is not yet, but people are working on it. When people say high temperature superconductors, a lot of these are high temperature in the sense that they're kind of at liquid nitrogen temperatures, right? Because the first wave of superconductors were way down at like single digit Kelvin degrees. And so, the superconductors that run MRI machines or the Large Hadron Collider sensor that's in the heading image here, those are higher temperature ones in the sense that they're able to work at, a mere 80 degrees Kelvin and not, like 4 or 5. That's high temperature now. But if we could have superconductors that could work at room temperature and pressure, what would that enable? And the first thing to think about there is that superconductivity has a bunch of different critical temperatures, pressures, and then also current density and magnetic field strengths. And these are all critical in the sense that as you drop the temperature down, the resistance drops and drops and drops, and then suddenly it falls off a cliff and goes to zero. And so temperatures below this critical temperature, any electric current flowing in the superconductor just keeps on flowing as if there were no resistance. But it's the same thing also with critical current density and critical magnetic field strength. And I think that's important to think about when you're thinking about the uses of possible room temperature superconductors. If they're only able to push tiny little currents before they lose their superconductive properties, well, it's not going to be used for large scale electrical switches or something. But as Al points out, it could be used for things like microelectronics and computers that don't lose heat to resistance and, will make your cell phone run for a longer time on a battery or something. So I think that's kind of the most likely scenario coming out of this. I don't think any of the candidate high temperature / room temperature superconductors have particularly high current thresholds. In fact, I don't think any of them have even been tested for it yet. They're all just kind of showing that they have this weird diamagnetic effect property. But nonetheless, that does not prevent people from going crazy and speculating in the comments, which I guess is the whole point of an Ask Hackaday article, to say, what can you do with this? And some of the cool things are, of course, they trap magnetic fields too. So you can make neat magnetic storage that never loses its storage because the current just keeps flowing in the loop inside there with zero resistance. What was the coolest superconductor effect seen in the comments?
Oh, how about the giving Mars a magnetic field?
And sounds good. Mars
Yeah,
could use
sure.
a magnetic field.
Time machines. Railguns. Someone says railguns.
Railguns,
is always the right answer.
The first comment is, of course, railguns. Thank you. Yeah, and that's probably right.
Does it make fusion any easier? I don't know. I don't think so.
Yeah, those are the big current, big magnetic field ones that, they would hopefully use to make magnetic containment things for fusion plasmas and stuff. And they're doing that already, but those are the ones that, require tons of liquid nitrogen, if not liquid helium, to keep them cool enough that they can, make magnets that stay magnetic at that incredible current density.
All right, so maybe it's Mr. Fusion then. Maybe we finally get our our flying cars that are Mr. Fusion, because you got little tiny magnets that can hold the reaction in. Maybe.
A lot of people have said things like, power transmission and stuff, and I think that's probably, where it falls down. That's probably not what we're looking at here with any of these new high temperature superconductors, is the kind of large current capacity that you'd need for that sort of thing.
Yeah, I mean, that was kind of always the killer app, the projected killer app for high temperatures superconductors that I remember back from the early 90s or so when I was kind of interested in this. And superconductors always seemed to be the high temperature ones that they were talking about, always seemed to be some sort of ceramic. And
Yeah.
I wondered what okay, great. I'm glad you can get superconducting in this ceramic, matrix, but what good does that do for, power lines? Like, look out the window and see the power lines draping from tower to tower and think, ceramics don't look like they're going to be much use in wires, and that seems like where we would really need this. But I don't know,
Right.
maybe that was just sort of the conjecture at the time that would be the best place to apply them, and maybe that's not actually valid anymore. I don't know.
The material science around superconductors is a little bit creepy as far as I'm concerned. It's a little bit mysterious. There's a video here, though, that goes into it a little bit. It says the video's title is, of course, Superconductivity Explained, and I'll give it a B plus on that. It explained more about superconductivity to me than I knew going in, but I'm still not 100% there. Anyway, give it a watch if you want a quick 5 minute get you up to speed.
Okay, my can't miss pick this week is Ethernet for Hackers Equipment Exploration. This is part of a series. I think it's the second one of the series by Arya, and read the first one as after I picked this article. The first one, I'll put a link to that in here too, because it's important. It's Ethernet for Hackers, the very basics, and that talks about what Ethernet is, the physical medium, the connectors, the wires, all the hardware stuff at the very lowest level. This current article is more about routers and switches. It's more about PoE. That's what really attracted me to this article, because I've got a couple of current projects that could probably take advantage of PoE, and I didn't realize the differences in standards that occur with PoE right now that can make things a little bit spicier than you want them to be. Anyways, I think this is one of those articles that you've got to just sort of read and reread. I can recall the first time I encountered Ethernet at all. I was working in a small biotech company, and I didn't have any idea how networking worked at all. I saw this rack of equipment in the hallway that had a bunch of blinking lights and things like that. And I asked the IT guy to just sort of explain it to me a little bit. And he probably did, and he probably did a fine job of explaining it. But all I remember from that explanation is watching the collision light blink on a hub or a switch or whatever it was at the time, probably a hub. And then him explaining that the maximum length of any segment in the network could be 100 meters, and didn't expand on that at all, didn't explain why that would be, and I still don't know what the collision light did. One of the things I didn't really realize was, how you could basically make a passive hub from just some resistors and maybe some diodes to actually split things out. I didn't realize that. Someone in the comments of this article did mention that you could. I mean, that's actually a security concern, that you could tap into an Ethernet line, very little else but some resistors and some diodes, and you've got your own connection into the network, which maybe isn't such a good thing for security. But like I said, power over Ethernet was the thing that kind of attracted me to this article, because I've got security cameras that I want to put up, and I always assumed that power over Ethernet was just power over Ethernet. You just plug it in and it works. Not so much. There's competing standards, and there's passive power over Ethernet, and then there's proper PoE that Arya explains. 802.3AF is a standard for, as I understand it, basically putting a DC bias on the communication lines, on the twisted pairs that are inside of the Ethernet. So basically just raises that floor up above, and then you take that out and you use that to power the device. Either that or passive PoE basically takes the unused pairs of wires inside of the cable and uses those to power things, and that's where it gets spicy because you don't know if the other end is expecting that, and you may be causing a problem for yourself.
Once you get into PoE, that is where things get ugly, interesting, and as you say, spicy, because we did a ghetto passive PoE system in my old hackerspace, actually, of our own devising. And Arya's point here that you should definitely label all of the wires that go into the system, careful passive PoE, be sure you know what you're connecting to what, is probably right, because as she mentions in this article, these wires are thin and they don't want to pass much current over long distances, right? So there's always going to be a voltage drop there. It's I squared R losses, right? It's proportional to current squared. So what you really want to do is get the voltage way up so that you don't have to push much current for a given amount of power. That makes your losses go down, but it also means that a couple wires on this thing that you're going to be plugging into low voltage electronics have, 12 volts, 24 volts, 48 volts on them. And that's good times. Plus, if you're wiring up the cables yourself, they are, as Dan mentioned, all funny crossed over, and that interleaving of the middle pair is bizarre. I don't know why you do that either, but you do. But it's also, that's a place you could make some mistakes, and please don't when you're wiring up cables like this yourself, because 48 volts makes things go fritz.
I built my house, the previous house we lived in, we built it in 2003, and I had a couple of 500-foot boxes of Cat 6 cable that I ran everywhere. Put Cat 3 in for phone, but I had network ports in every room of the house, everywhere I thought, I might need one. And by the time we actually, moved into the house and we were a couple of years on, I didn't have anything plugged into the network. It was all Wi-Fi. And I think a lot of people are probably in the same boat. Wi-Fi is pervasive, so they just don't bother plugging stuff in anymore. And I think that's the right answer for most things. But when it comes to, things that, first of all, that need power, you're going to run a wire anyways. Why not make it a Cat 5 or a Cat 6 cable? There's things like security cameras that don't have any business being on Wi-Fi. Certainly don't have any business being on a regular segment of the land that has access to the outside world. There's still a call for Ethernet for sure. And that's what I'm coming up against now is running some security cameras that are going to be PoE and on a separate VLAN. So good timing on the article, Aria. Thank you.
And that wraps it up for this week's Hackaday podcast. Thanks very much for listening. The links you will find in the show notes, hackaday.com/podcast. Cool hacks you will send to us by email, tips@hackaday.com. And until next week,
keep on hacking. My turn.
I squared C's. I mean, it's I2C. It's inter IC. So it's It's probably I squared C. Blah, blah, blah. And the other thing, what was the other bit of news? Oh, damn it. Reversion. Blah, blah.
First up for me, let's see. Where is my stuff? Okay. Elliot, you still there? Whoa, what happened there?